Today we're going to talk about rational and irrational numbers. To introduce us to this, I've got a picture that I took when Mr. Peters and I traveled out west a few years ago, and this is Devil's Tower in Utah. A definition for you first. Rational numbers. Rational numbers are any number that can be expressed as the division of two integers. These kinds of numbers are repeating decimals, terminating or stopping decimals, integers, and fractions. For example, 0.3 repeating. Remember that line above your number tells you that it's repeating. So 0.3 repeating, or 0.33333 forever and ever and ever. 75 hundredths, that's 0.75, that truncates or terminates, it stops. 2 sevenths, 5, and negative values fit into this as well. So I've got 4.5 and negative 11. Your turn. List 3 rational numbers that were not mentioned on the previous page. Since there are infinitely many rational numbers, I won't have a correct answer on this one, but we will be checking these tomorrow in class. We're going to be looking at several different ways to express rational numbers today. We will the next video be looking at irrational numbers. Firstly, we're dealing with writing a terminating decimal or one of those stopping decimals as a fraction. For our steps, you first write the decimal how you say it. This deals with place value. So remember, after your decimal, you have tenths, hundredths, 1,000s, 10,000s, 100,000s, 1,000,000s. We'll hang out in these tenths, hundredths, thousands places here. After you write it how you say it, you simplify. For example, we're going to write 4 tenths and 6 35 hundredths as simplified fractions. So when you write it how you say it, thinking back to that chart that was on the last page, we've got one number behind the decimal, that's our tenths place. So 0.4 we would read as 4 tenths. To write that as a fraction, we write 4 tenths. Write it how you say it. From here we can simplify. Both 4 and 10 are evenly divisible by 2. Four divided by 2 is 2. 10 divided by 2 is 5. So 4 tenths can be expressed as the fraction 2/5. For 6 35 hundredths, we're going to approach it the same way. We've got our whole number, so I'm going to go ahead and write this larger there. And then write it how you say it. Tenths, hundredths, so that's 6 35 hundredths. When you write it how you say it. 35 and 100, we can divide both of those by 5. Six comes down and comes along for the ride. 35 divided by 5 is 7. 100 divided by 5 is 20. So 6 35 hundredths is the same as 6 7/20. If you have a fraction like 0.1, which is just your 1/10, when you write that how you say it, 1/10, that is simplified already. So there are occasions where you may not have a common factor to divide out. It may just already be simplified as it is in this case. Your turn. You're going to write 15 hundredths and 2 37 hundredths as simplified fractions. Pause your video now. Did you get a simplified version of 15 hundredths as 3/20ths? Did you get 2 and 37 over 100 for a simplified fraction version of the 2.37? If you got both of those answers correct, give yourself a big giant grinning smiley face. If you didn't get them right, put an X. Go back, try again, see if you just forgot to simplify, or see if you need to go back and look at the last example. Once you figure out where your mistake or mistakes were made, and you get the correct answer, put a circle around your X. Our next step we're going to look at is writing a fraction as a decimal. For this, there's really just one step. You're going to divide the numerator by the denominator. An easier way to think of it is top in, bottom out, divide. For example 3, we're writing 1/6 and 5 1/8 in decimal form. So for 1/6, top in, so if I've got my little division right here, I'm going to put the top in, the bottom on the outside, and divide. So 1 is my dividend, 6 is my divisor. Remember, when you are dividing, 6 can't go into 1, so I'm going to put a 0 there. I'll put down a decimal point and carry that up to the quotient area and start adding a 0. 6 can go into 10 one time. Ten minus 6 is 4. Well, I can still keep going, so I'm going to extend this out and add another 0. Carry that down. 6 goes into 40. Well, 6 times 6 is 36. 6 times 7 is 42, so 42 is too big, but 36 will work. 40 minus 36 is going to give me 4. I'll add another 0. Carry that down. And I've got 40 again. 6 goes into 40. Oh, hey, that's what we did last time. So because I'm still going to, every time it looks like, have 40 after I bring down the 0, and then I'm going to have that 36, since 6 times 6 is 36, this value is going to keep repeating up here. I'll have another 6 and another and another and another. So we would write that as 0.16 with just the line over the 6, since only the 6 is repeating. If I put it over the 1, that would mean it was 0.16161616, but we don't have that. We just have 0.1 with just the 6 repeating. For the 5 1/8, again, I'm going to do top in, bottom out, divide. I'm going to put my 5 over here off to the side because I know that I've got to include that for my answer piece. We just have to figure out what the decimal is afterwards. 8 won't go into 1, but 8 will go into 10. 8 goes into 10 two times. 8 goes into 10 one time. 10 minus 8 is 2. Got a 0 that I need to add, bring that down. 8 goes into 20 two times. Which is 16. 20 minus 16 leaves me with 4. Then, let's see, bring down another 0. 8 goes into 40. Well, 8 goes into 40 5 times, and that goes an even amount of times. So this is a terminating or a stopping decimal here. since we end up with a remainder of 0. So this piece here after that decimal point is going to come right after the 5. And our final answer will be 5 and 125 thousandths. 5 and 125 thousandths. Your turn. You are going to write 1 and 7/9 as a decimal. Pause your video and give it a try. Did you get 1.7 repeating? If you did, give yourself a star. If you didn't, give yourself an X. Go back, see if you can find your mistake, which may involve going back to the previous example. If you figure out where you went wrong and you are able to write your 1 and 7/10, put a circle around your X. The last piece we're looking at today is writing a repeating decimal as a fraction. For this, the steps are a little better illustrated once we have the example, so don't get frustrated with the steps right now. The first thing you're going to do is count the repeating digits. So if you've got one number repeating, you've got 1. If you've got 0.234, 234, 234, 234, that's 3 digits repeating. However many digits you have repeating, you're going to put it in a fraction over that many 9s. So if I've got 0.23 repeating, I've got 2 digits repeating, so I'm going to put that over 2 9s. If I have 4 numbers repeating, I'm going to put it over 4 9s. If I have 17 numbers repeating, I'll put it over 17 9s. We won't get into fractions that big. Then you'll simplify the fraction. So let's look at this 0.5 repeating. 5, that's only one number, so I've got one number repeating, and I'm going to put that over 1 9. Well, 5 and 9 don't have any values in common other than 1. They're relatively prime, so that's my answer. For this part of the example, I've got 2 digits repeating. Since there's 2 numbers repeating, I'm going to put that over 2 9s. 15 and 99, I can divide both of those by 3. 15 divided by 3 is going to give me 5. 99 divided by 3 is going to give me 33. So 0.15 repeating will simplify to 5/33. Your turn. You are writing 0.54 as a simplified fraction. Pause your video at this time. Did you get an answer of 6/11? If you did, give yourself a Mrs. Peters curly-headed smiley face. If you didn't, give yourself an X. Go back and find your mistake. Once you do, put a circle around it. You have 4 homework problems. The first 2, you are going to express these fractions as decimals. For the next 2, you are going to be expressing these decimals as fractions. Show your work, and we'll talk about it in class tomorrow. Have a great day.